So this is this one from section 1.5, and the question is, given f of x equals to 8x minus 3, can you find the inverse? That was the question. If you remember the steps for finding the inverse, I says replace f of x with what? With y. That was the first step. So this question becomes y equals 8x minus 3. Step number 2, interchange x and y. Switch them. X becomes y, y becomes x. So x equals 8y minus 3. And what's step number 3? Solve for y. These are the 3 steps of finding the inverse. Solve for y. X plus 3 equals what? 8y. What's y equal to? X plus 3 over 8. And that's your inverse function. This is your f of negative 1 of x. Now, if you want to prove you did it right or not, then to test it out, you can do one of 2 things. This is, if they're really the inverse of each other, if you take f of the inverse of x, it should give you x. Or, if you take the function of the inverse of x, it also should give you x. Doesn't matter which one. So here's my f of x. I'm going to prove it, that that is correct. And this is the inverse. So I don't have to look at the other page. I can just take it out. I'll do this one just because it's on the bottom. You know, so I don't have to drag any lines to it. So I'll take this one. So what is f of the inverse? Well, the inverse happens to be x plus 3 over 8. And when you see that, it says go to the f function and do what? And replace x with what? With x plus 3 over 8. With this one. F of this one. Replace x in the f function with this one. So here's my f function. 8. I'm going to take the x out and put what? X plus 3 over 8. Then subtract the 3. So I went to this function right here, and I'm replacing x with x plus 3 over 8. Now let's look at the math. The 8 will cancel each other out, and you end up with what? X plus 3 minus the 3, which is what? X. Bingo. That is the inverse. Now I have a few questions from chapter 1, section 6, and let's look at some of them. So this is from section 1.6. One of them was number 4, question number 4, which says solve for x. And here's the question. 8 to the 5x equals 78. What you see there is an exponential equation. The only way to solve exponential equation, well, one of the common ways, I shouldn't say the only way, one of the most common ways to take the log or the natural log of both sides of the equation. And since that number is an 8, it's not an e, it's not a 10, it really doesn't matter if you take the natural log or the log. So I'm going to take the natural log just because it's 2 letters versus 3, I'm lazy. That's the only reason. And the natural log of the other side. The natural log of 8 to the 5x should equal the natural log of 78. I think property number 6 for the log, I think it was rule number 6. It says if you have exponents, what can you do with the exponents? Move it to the front. There's my exponent. I can move it, put it in the front. So that becomes 5x times the natural log of 8 equals the natural log of 78. I can actually use my calculator, but I'll wait a few minutes. What's 5 times the natural log of 8? Both are numbers. 5, the natural log of 8, x equals the natural log of 78. So if you want to get x, you divide both sides by what? 5 ln of 8. So these guys will cancel. X equals ln of 78 over 5 times ln of 8. And if you go to your calculator, you can write the whole thing in one shot there. I could actually found the answers to these using my calculator early and plug them in. I opted to wait there. So ln of 78, close your parentheses here, divided by, open parentheses, 5 times ln of 5, close parentheses, close parentheses. So notice my parentheses here. I don't know if you can see them. ln of 78 divided by, I have a whole group of parentheses here to make sure I'm dividing by the whole thing. 5 times ln of 5 equals 0.54. Oh, what is it?
It's the natural log of 5 ln of 8, not 5 ln of 5.
Oh yeah. Thank you. So let's go back to the entry here. And that was here, should have been 8. Good eyes. Enter. 0.419.
Professor,
Yep.
it says now apply the following logarithm property to 25. Can you tell us? I don't know this. I don't know, like, how to work. Yeah, this part looks like a formula or something.
I'll come back to it. Let me just finish these questions. And I'll check and see what you're asking there.
I've actually saw it.
I just don't want to like wait and wait dead air, because that file becomes massive on YouTube and takes hours to upload them. I'm telling you, it takes me about 2 hours every day to upload them. Let me try number 6. Again, section 1.6. I have 1/4, I like this one, to the x minus 3 equals 64. Now I can use a calculator for this, but I don't think we need it. Why? The 1/4, I can write that as what? 4 to what power? Just the 1/4. Minus 1, very good. Power to power, what do you do with the exponents? You multiply them. Which will make it 4 to what power? Minus x plus 3. So I'll put the 3 first. Instead of minus x plus 3, I'm going to put 3 minus x. Doesn't matter which one you write first. The 64, can you write the 64 as 4 raised to a power? 4 to the power 3. This side is equal to that side. The base is the same. That means what? 3 minus x will have to equal to what? 3. What's x equal to? 0. Question on this one? We good? Okay. Number 8. What do we have next class? A test on chapter 1, so make sure. If you like to use your laptop, feel free. Only have 20 machines working in the lab. I mean, I have other labs I can move you to, but I got 20 machines in the lab, so if you want to bring your laptop, we have plenty of room to sit out there and you can log in with your account and do the test because we're going to be in the computer lab.
Are we allowed to use calculators?
Non-graphing, which I have them, if you need them.
Non-graphing?
Non-graphing calculators, yep. For this, actually, there's nothing the graphing calculator can do for us, so you can even use the TI-83, 84. But soon enough, once we get to integration, all the fancy stuff, you will not be allowed to use them because it does the work for you. Now this one, I got the power there, 4/3. How do you get the power 4/3 here? What's the easiest way? I could actually.
You put it in the front?
I could. I wasn't thinking that direction, but I could do that.
What were you thinking?
I was thinking of just raising this to the power 3/4. Why 3/4? What is power to power? 1, right? That becomes, I mean, you multiply, that becomes a 1. If I raise this side to the power 3/4, I got to raise this side to the power of what? 3/4. So that would be 81 to the power 3/4. What does that mean, 81 to the power 3/4? That is actually the 4th root of 81 cubed. That's what it means. Or if you go to your calculator and you type that in, it should give you an answer of 27, I think.
Yes.
So x plus 3, because the 4th root of 81 is 3. What number, if you multiply it by itself 4 times, the answer is 81? 3. 3 times 3 times 3 times 3. So the answer to this 3, raise it to the power of 3, that's 27. Take the 3 there, it becomes x equals what? 24. So that was number 8. And the last one. Any questions here? The last one from the questions that you gave me is number 14. Which says f of x equals e to the 9x minus 3, and they want you to find the inverse. Step number 1, replace f of x with y. Step number 2 is what? Interchange x and y. And step number 3 is solve for y. And this is actually where the fun starts with this one, solving for y. Take the minus 3 to this side, you have x plus 3 equals e to the 9y. That's an exponential equation again. Best way to solve it, take the log of both sides or the natural log. The fact that we have an e there, I'm going to lean toward the natural log. Natural log of this side, natural log of this side.
Was the negative 3 in the power or was it not?
Was it the power? Okay, if it was the power, then no. I'll just leave it there. Yep.
No, it wasn't the power.
Was it in the power?
Yes.
Okay, so yep. So I guess, yeah, the minus 3 was up there in the power. Then I can't take the minus 3 here. Go through boxes of these erasers. So we have x equals e to the power, I'll put these in parentheses, 9y minus 3, we know that's the power. Okay. Now let's take the natural log of both sides. If you remember, property number 6 is you can take the exponent to the front. That's the natural log of x equals 9y minus 3 times the natural log of 1. I mean, the natural log of e. What is the natural log of e? 1. The natural log of e is 1. Why? If you remember from the natural log or the log, the ln of e, it means log base what? E of e. And if you call that x, going from log to exponential, it says to what power? We need to raise the power to, so the answer will equal to e. And the only way that will equal to each other, if x equals to what? To 1. So the natural log of e is always a 1. Just like if you have the common log. The log of 10 is always what? A 1. If you have 10 to the power, we always take the common log. If you have e to the power, we take the natural log, because these guys will cancel each other out. So here we have the natural log of x equals 9y minus 3. Now let's solve this one. Take the minus 3 to this side, becomes 3. 3 plus the natural log of x equals 9y. And to solve it for y, y will be what? 3 plus the natural log of x divided by 9. What's the inverse function now? Three plus the natural log of x divided by the 9. That's your inverse function. Again, if you want to prove to see if you did it right, take f of the inverse or the inverse of f and see if the answer is x. Last time I did f of the inverse, so I'll do the inverse of f here. If the answer is x, they are the inverse of each other. Well, f of x is what? Let's replace f of x by its value, which is what? E to the 9x minus 3. And this one is saying what? Go to the inverse function now. And which is this one. And every time you see x, you're going to take it out and put what? E to the 9x minus 3. The natural log, take the x out, put e to the power of 9x minus 3. A shortcut for the future, when you see it, you don't have to derive it. The natural log of e to any power, it's always going to equal the power. Always. The common log of 10 to any power is always going to equal the power. So if you remember these two, you can save yourself a few steps there instead of trying to derive that this whole piece is equal to 9x minus 3. The natural log of e to the power, there's the natural log of e to that power, should equal the power of this. So that should equal 3 plus natural log of e to the 9x minus 3 is just 9x minus 3. Using this rule right here. And what happens to the 3 and minus 3? They cancel each other out. 9x over 9, which is what? X. And they are the inverse of each other. So this just to prove that what we did is really correct.